When we look at a molecular orbital diagram that has been filled in to show the orbitals that are occupied by electrons, we can use this information to calculate the bond order for a molecule. This is done by comparing the number of electrons inhabiting bonding orbitals, orbitals which increase the bond strength, and the number of electrons inhabiting antibonding orbitals, orbitals which decrease the bond strength. The way bond order corresponds to our understanding of molecules is that it dictates the number of pairs of bonding electrons between two atoms. So, a bond order of 1 corresponds to a single bond. A bond order of 2 corresponds to a double bond. And a bond order of 3 corresponds to a triple bond. To calculate the bond order, we simply take the number of electrons in bonding orbitals, subtract the number of electrons in antibonding orbitals, and divide the result by 2. The bond order will tell us the strength of the bond between two atoms, as a higher bond order means more bonds and therefore a stronger interaction. Let's go back to our orbital diagram for the oxygen molecule. We can see that there are 8 electrons in bonding orbitals, and there are 4 electrons in antibonding orbitals, which are the ones with the stars. Let's plug those into the equation and see that we get a bond order of 2, which corresponds to a double bond for an oxygen molecule. There can be situations where there is a bond order between two integers, which would tell us that there are partial bonds present, such as is the case for molecules that have multiple resonance forms. And if the bond order is 0, that means a stable bond between the two atoms will not form. So, molecular orbital diagrams can tell us a lot about a molecule, including the strength of the bond between two atoms, which is dictated by the bond order.